So let's plug in some values of random bases, each with exponent 0 or power 0, and see what we get. Without even doing that, we know that all of them are going to be what? 1. Anything to 0 is 1. And just to prove, I'm just going to get my machine up. There we go. So 3 to the power of 0. 1. Of course, no surprises there. Okay. Put it in a bracket. 5, negative, close the bracket, and then raise to 0. 1 again. Yeah, that's my point. All of them are 1, whether they are a decimal or a fraction or whatever. How about this one? Everyone, how about that one? This one. Oops, my bad. How many people say this is also still 1 at the end? How can you prove to me that this is 1? You want to say everything we put to a power of 0 is 1. I agree. But there's a multiplication down in the base here. Okay, Briar, go ahead. Yes. Or you multiply them together, you mean? You multiply them together, right? You just said add them together. Okay. So basically, what do? We do BEDMAS, right? What's 3 times 6? 18. So really, this is just what? 18 to the power of 0. What's 18 to the power of 0? Another 1. There you go. So it doesn't matter, even if the thing inside is an expression, it's also 1. How about this one? Do you think it's also 1? What's your base here? X. Do you know what X is? But what would X turn out to be anyway? X always turns out to be a number, a value. All numbers to 0 are what? 1. So we're good. You see, even though we don't know it, we know eventually it'll be a number, whether we found it or not. Okay, how about this one? How many variables do we have here, by the way? 3, X and Y and Z. All of them will turn out to be what? Numbers anyway. If they could be the same number, they could be different. We don't care. 1. Okay, how about this one? I don't know. Let's plug it in. 0 to the power of 0. Let's say what the machine says. 1. So even in the special case of what? Of 0 to the power of 0, we're going to say it's also what? It's 1. Okay? That's all good and fine. Yes, everyone. How many people are getting error when they do 0 to the 0? 0 to the 0 is a special case. Okay? Depending how the calculator is programmed, it could give you what? Or it could give you what? Math error. Okay? In this course, what did you get? Math error. In this course, we're going to say it's going to be what? Just to make sure that we have no exceptions to this rule. Okay? But again, don't worry. Yeah, so it's fine. All right? So again, by the way, I am never going to give you what's 0 to 0. Okay? So I'm always going to what? I'm always going to stay away from that case. Okay? We're always going to give you what? Something to 0. And that something will never be 0 itself. Okay, so I want you now to put your pencils down and let me just give you a very easy explanation. Why is it 1 every time? Because it's a weird case. Whenever you associate something with 0, usually the answer is what? 0. But in this case, the answer was always what? 1. So let me explain to you why. So just in less than 3 minutes, you'll actually understand why. Okay. Okay. Question for everyone. What's 5 divided by 5? Guys, come on. What's 5 divided by 5? What's 16 divided by 16? What's negative 5 divided by negative 5? Uh, hold on. See, whenever you put a negative in things, people get, wait a minute, let me think about this. So 5 divided by 5 is what? Why? Because when you divide something by itself, you always get what? So when you divide negative 5 by negative 5, technically, are you dividing something perfectly by itself? So the case still applies, and so what? What if you divide negative 5 by 5? Yeah, you still get a 1, but now negative wins because there's only what? 1 of it. Do you see what I mean? So always negative divided by negative gives you what? Positive, which is why it's just a 1. Okay? So let's say, so we know, so let's write this down. We know that 5 by 5 is the same as negative 3 by 3 is the same as 0.78 divided by 0.78. All of these are equal to what? Come on. All of these are equal to what? All of them are equal to 1 because each one of them is something divided by itself. Okay, good. Okay, now, what about this one? What about, everyone, eyes on the screen? What about, yeah, what about, I don't know, let's say, let's pick an exponent with a number. Let's say 7 to the 3. Don't ask me why I picked 7 and 3. I just randomly chose numbers. So what about 7 to the 3? Okay, let me just make this one smaller. Can someone tell me what rule applies here? Which exponent rule that we covered so far applies to this one? No. Which exponent rule applies? Is it the multiplication? Is it the division? Is it the negative exponent? Which one is it? I mean, by the way, this is a fraction. So what? A fraction is just another form of what? Division. So here we have to apply the division rule. What is the division rule? Who knows? It's a part of your quiz. Come on. What's the division rule? So what do you do with these powers? Do you add them or subtract them? All right. So far, I'm not teaching you anything new. We've done this before. What about 7, 3? We get 7 to the power of what? 3. Subtract what? Hey, what's 3 minus 3? Just 3 minus 3. Interesting. But what is 7 to the power of 3 divided by itself? I know I'm going in a circle here, so it might be confusing. But see what I'm trying to do. I established with you that anything dividing itself is always what? 1. And then I wrote something divided by itself, right? But it looks complicated because it's not just a number, it's a 7 to the 3. No problem. According to what we did 2 days ago, I think 2 days ago or 3 days ago, this 3 subtracts from this 3, right? So what do you get? 7 to the power of what? But this also happens to be what? Something divided by what? Something divided exactly by what? By the same something. But 7 is the same as 7 to the 3 divided by 7 to the 3, which is equal to what? What did we just conclude? What did we just conclude? That 7 to the 0 must be equal to what? Did you see the trick here? The trick here, okay, let me just explain to you in words. Everyone, pencils down and just listen to me. I could not have taught you this trick until I taught you what? The fact that when you have a division, what do you do with these two? You subtract. When you subtracted them, what did the 3 do to the minus 3? It gave you 0. But then I went back to what we learned from like grade school, and I told you, as far as you're concerned, this divided by that is the same as what? 5 divided by, or minus 3 divided by minus 3, which is always got to be what? So I just told you, you know that when you divide something by itself, you should get 1. But here, when you divide something by itself in this way, you should also get what? 7 to the power of what? This guy and this guy are the same, right? Both of them are equal to what? Both of them are equal to what? So that means what? 7 to the 0 must equal to what? Must equal to 1. I could not have taught you that until I taught you what? The subtraction trick. That's basically it. Okay? So what does this mean? Let's just write one last statement. I'm just going to say it first, and then we're going to write it. We're going to write what? So anything to 0 is like what? Something divided by itself, which is what? There you go. So in simple words, anything to the power of, this is a bracket, let me just put a good bracket, anything to the power of 0 is something divided by itself. Which is, you actually know something now that many grade 11 and grade 12s don't know. You ask them, why is it 0? They tell you, why is anything to 0 equal to 1? They will tell you, well, plug it in and see, it's always going to give you 1. You're telling them, yeah, I know that happens, but why? They will be like, I have no idea. They have no idea why. Which means, sadly, they still don't understand this rule as much as you do. Okay? You can't teach this, for example, to a grade 9 student. Why? Because they have not done the trick of what? They don't know that when you have an exponent divide by another exponent, what do you do with these? You what? Do you add or subtract? Yeah, so you can't teach it to a grade 8 or grade 9 because they don't know that rule. Okay? But now we know it, so we can relate the two together. Okay? So, and that's why anything to a power of 0 is 1. Okay. So the rule says any number or expression to the exponent 0 is equal to 1. What does this one say here? B does not equal what? That's why this one is here, because some of you, when you plugged it in, what did you get? Sometimes it gives you what? Math error. So again, this is a special case. So I want you just to write here. 0 to 0 is a special case. Special case. Don't worry, I will never give you a question about 0 to 0. Maybe I could give it to you as a what? As a true false. Like, for example, I could say, well, hey, maybe I'll give you a hint into your next Google form test. Maybe I could give you what? 0 to 0 is always 1. Is that statement true? Well, it was, yes, according to my machine, but according to your phones, they give you 0 or they give you a math error. Yes, so when you say 0 to 0 is always 1, depending on how you look at it. Don't worry, it's a special case. We don't care about it. Okay? That's all we need to know about the what? The anything to 0 case. Done. That's it. Okay? All right. Now let me give you the second part of today's lesson, which is the last exponent rules we have to deal with. Okay. Okay, everyone. In this lesson, we do how many rules? How many? Come on. Eyes on me. How many? 3. We will do a rule where there's what? Multiplication, but where? In the base. Not in two bases, in the base itself. Then we're going to do what? Division, also where? And then we're going to do what? Inside. Okay. So, everyone, here's the first rule. Multiplication in the base. Multiplication in the base. If there is multiplication in the base, which means you have to put it in what? Come on. You have to put it in brackets, obviously. By the way, question for you. What's the difference between this? To talk about, what's the difference between this and this? Hamza, go ahead. In this one, the 7 is attacking how many things? It's on top of this one, and it's on top of this one. So how about here? Thank you. So again, that's why we use brackets, because computers or calculators never know what we mean. You could write this, and you say, please do these first, and then do that. No, a calculator would do this first, and then multiply just by what? 5 and 3. So whenever you do brackets, you force the calculator to do whatever you want. That's why we use them. Okay? So what's the rule here? The rule is the power attacks, I like the word attacks each part of the multiplication independently on its own. When any base is negative, use what? Please use brackets. So that means the rule says what? A times B times C times D. Go ahead. Put an arrow on top of this one. Yes. 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 So what does this become? A to the power of what? Times B to the power of? You keep going. Yep. So a to the power of n. Now, can you write this? Can you just write it this way? What do you think? How many people agree that when you have variables, you can write them without the multiplication sign? Raise your hand if you think so. You're absolutely right. Everyone, when you have variables and you don't have something between them, what's technically between them? A multiplication sign. So feel free to put nothing. Feel free to put multiplication sign. Feel free to put the dot. Or feel free to put each one in its own what? But come on, we already had brackets. Do we want to see any more of them? The whole point of putting the n inside is that we don't want to see the brackets anymore. Unless your base is what? Positive or negative? Negative. Then you have to be careful. So I'm just going to make it easier for you today. I'm going to erase the brackets. And I'm not a big fan of the dot. I don't like the dot, but I definitely like the multiplication sign. There we go. Okay, let's apply this basic rule to some examples. Okay, everyone, question for you. Listen up. How many ways are there going to be? Listen. How many ways are there going to be to do anything like this? One or two ways. Can you tell me the way to do this without using what we learned today? Breyer said it actually. What's the way to do that? 5 times 3 to the power of 2 without using what we just learned 15 seconds ago. Hold on. Say that again. Everyone listen up. Say that again. 5 times 3. By the way, Hamad, you still say multiply 2 by the answer. Are we multiplying 2 by the answer? Or what are we doing? We're doing a power to the 2. No, don't say multiply, because multiply, it has to be on the same level, right? How many people want to say that as well? You did, right? So does that use what we learned today, or does that just use BEDMAS? That just uses BEDMAS. Now, here's the question. If you did it that way, and it was a multiple choice question, would I know which way you did it? If you did it that way, and it was a multiple choice question, would I know that you did it the old way, not the new way? I wouldn't. But what if it was a show your work? Would I know that you didn't use my way? Yes. So everyone, if I give you this question, and I say what? Solve it using the what? The exponent rules, and you do it the way that Hamza or Hamad said, you are not going to get full mark. Because you didn't use the what? The exponent rules. You just went back to what? BEDMAS, right? What would be the way to do it with exponent rules? Yes, put the 2 on top of how many things? 2 things, exactly. That would be the exponent rule. So let's just go and say, you don't have to show me the arrows. You can just jump straight to the result. 5 to the 2 times 3 to the 2. How much is 5 squared? 25. How much is 3 squared? What's 25 times 9? 225. You got it. So 200. How can you check your answer? Using the way that Hamad said. Do it the easy way. What's the easy way? Just basically say what? That thing here becomes 15 to the power of 2. Hey, what's 15 squared? 2. It has to be. Otherwise, nothing makes sense anymore. So that's the other way. And all of them are like that. Okay, how about this one? Can you do BEDMAS here? Hold on. Can you multiply x times y times z? I mean, do you even know what x and y and z are? So as far as you're concerned, you can never multiply these 3 things together. The best you can is just put them next to each other. But you can never actually multiply them on a machine. So what do you have to do? You have to attack the 6 to each one. All right. So what does this become? X to the 6. Do you have to put a multiplication sign? Yeah, you know what? I would rather you do not put a multiplication sign next to an x, because they could look the same. Just write the variables next to each other. Can you do any more than that? No, because you have no idea what the x or the y or the z are. Done. Okay, this one. Come on, would this one be easier to do the old way or the new way? by the way, it's always easier to do it the old way, right? Because you just fill the, sorry, not fill. You just do the brackets, and then you just raise it to the power of what we have here, to the power of 3. So you know what? Let's do it the easy way first. What's negative 7 times negative 4? Negative 7 times negative 4. Positive 28, because negative with a negative cancel out. So technically, this is equal to 28 to the power of what? Wow, that's got to be a big number. Okay, let's see how, if it's too big, we might not bother actually what? Writing the value itself. Don't worry, I'm not going to ever give you like a big number to write on quizzes and tests. So let's see what it is. 28 to the power of 3. That wasn't actually too bad. We can write that, 21,952. Okay. What would be the other way to do this? Come on. Today's way. What do we do? Yes. Minus 7 in a bracket to the power of 3 multiplied by minus 4 to the power of 3. Okay, question to you, everyone. What's minus times itself 3 times? Nice, minus. So all I have to get now is the 7 to the 3. Sorry, not that. 7 to the power, 7 times 7, 49. I think it's 243. 343. Sorry, that was the 81. My bad. Yes. Thank you. 343 times. You might say, why aren't you putting this in a bracket like here? Yeah, you can. I have no problem. So, but I'm just gonna skip it for now. Times what's negative 4 times negative 4 times negative 4? Another what? Positive or negative? Another negative. What's 4 times 4 times 4? 64. What's negative times a negative? Perfect. So at least we got that part right. And it better be 21,952. Otherwise, I don't know what I'm talking about. It sure is. Well, I built a career of 21,952. Done. That's it. Okay? It's nice to know multiple ways of doing the same thing. Just in case you mess up with one, at least you have what? You have a chance of getting the marks from the other one. Okay. Can someone tell me how similar that is to the one above it? Almost. Is it almost identical? We have a what? We have a number. But do we still attack the 4 to all of them? Yes. By the way, the biggest mistake that people do, even in my physics course, is that they put what? Look, some people do this. What's the only mistake? But it's a big mistake they did. They exactly. They did not treat the 2 as well as they treated everything else. By the way, this is very common, and so many people, even ones who finished all math in high school, do it. They're just stuck with what? Putting it on top of the variable, not the number. So there we go. Okay. Am I going to be able to do anything with the variables? No, but am I able to do something with the 2 to the 4? 100%. What's 2 times 2 times 2 times 2? 16 indeed. 16, x to the 4, y to the 4, z to the 4. That's my fancy z. Nice. Okay. That takes care of what? Multiplication in the base. If the base or the bracket has a multiplication in it. Okay, let's do the other way, which I'm already saying in my notes, which we what? We what? We kind of covered it. We did. Actually, we did almost in the first couple of days. Okay? Did we do things like this before? Did we do this before? Yeah, I did it without teaching you the rule. Technically, it's a very easy rule. So let's just do it officially right now. What happens to the n there? No, no. By the way, the n here is assumed to be positive. So do you need to flip or no? No, unless it's a negative, then you flip. If it's a positive, you never ever flip. So what do you do here? Nothing. You attack the n here, and you attack the n here, and you put a to the n over b to the n. So it's kind of like the multiplication case, but instead we have a division. Okay, great. Let's do all of them, which again, we did very, very, very similarly in the last couple of days. Okay, what's this one? This is 4 to the 5 over 3 to the 5. What's 4 to the 5? 1,000, 0, 2, 4. 3 to the 5 is 243. Do you think this simplifies? Remember, the big numbers are always scary. But how can you tell that this one can never simplify? What you go to the what? You go to the original one. Does 4 simplify with 3? Nope. They're as small as they can get together. Done. You don't have to bother. You can. By the way, if you want to check, it's just gonna take you a long time because you have to list all the what? All the dividers or divisors, depending how you say it, of 243, all the divisors of 1024, and see if they agree on one. None. They will only agree on what number? What number? All numbers divide 1. Other than that, you cannot guarantee it. Done. Okay, next one. 4 to the 5. Is this correct? I should use a what? Thank you. 1024. What's a negative times itself 5 times? Negative, because one of them is not going to pair up. Okay, what's 7 times 7 times 7 times 7 times 7? 7. So what's up? What was the question? You sure? Okay. 16. Should should I leave it like that? It's not wrong, but should I leave it like that? Not can I, should I? Why? Haley? Do math teachers like or do math style or ever go with negative at the bottom? Where are the only 2 locations you can put the negative? Beside or above. So you can either write it this way, which is my favorite, to be honest. I like to put the minus with a number. Or, Sadia, what did you say? Where? Beside it. So you put the minus, and then you write the whole fraction by itself. Okay? One location, one location, one location. 2 of them are good. One of them is not that popular. All right, whatever. I mean, I did not make the rules. Someone else did. Okay. Next. How should you do this one simplified even before you start? By the way, we did this one yesterday or something similar. 2 negatives over each other. What do they do? Yes, they completely what? It's like it doesn't exist anymore. So feel free to write this now. I mean, you could have done, everyone, you could have done it this way. Look, could you do it this way? How many people say you could do it this way? Yeah, you're right. You applied the rule. And guess what? You're going to get 2 negatives on top of each other, which will do what to each other? They will cancel out. So you could have done it at the beginning, or you could have waited at the end. Either way, you get full marks. So what's the negative 8 to the 3? Well, I know it's a negative. Oops, not this. 8. How much, sorry? 512, thank you. And this one, I know it's negative 27. And the negative cancels the negative. So guess what? It will survive just like that. See? There are so many ways to doing exponents. It's good to be able to do them multiple ways, or to at least be able to. All right? How about this one? Can you cancel the minus? This one. Can you? No, no, no. Can you, sorry, forget the square. Can you cancel it within the fraction itself? No, sorry, yes. You can't. Okay, if you think, cancel it with what? It needs another minus here, look, to cancel with. It doesn't have it, so it stays. All right, but at least we know it's going to go away. So it's minus 3 squared divided by 5 squared. 9 over 25. So Hamza, that's what you meant by canceling it, right? He meant canceling it because of the power. I meant canceling it by the virtue of another minus. Good, good, good. Okay, this one. Can you cancel the minus right now? Can you cancel this minus between these two? No, no, no. Between these two. No, you can't. Good. It's gonna cancel, but not because of that. Let's keep going. So obviously this will be what? Negative a to the square or to the 2 Sorry, either say negative a squared or to the 2. You never say to the square. Everyone, let's do this first. Is this correct? Is it half correct? Half correct. Is at least one part of it correct? Yeah, this part is correct. What did I miss? I missed 2 on top of the 2. Yes. All right. How about the top? What's a negative times a negative? Just twice. Thank you. So feel free to write positive. You don't have to. And what's a times a? A squared. What's a times a times a? A cubed, like to the power of 3 and so on. Okay, what's the only last thing I can do to this to make it slightly simpler? Only one thing to do. Sabine? 4. Why leave it 2 to the 2? 4. The simpler you can make it, the more full marks you can get. So just a squared. Done. Okay, this one. How many things is the 3 on top going to attack? How many things in total is the 3 on top going to attack? How many people say 4 things? I say 4 things. Why? Because it's going to attack this one, and this one, and this one, and this one. Yeah. So, but let's do it step by step. Obviously, you have to do it this way first. 3x all to the 3. 4y all to the 3. How many people said 2 originally instead of 4? If you said 2, you're still technically right. Because first, it attacks 2 things. And then it attacks what? 2 in each 2 things. So whether you said 4 or 2, you are correct. All right? What happens here? 3 to the 3. Yep. X to the 3. I don't know. I leave it as just x to the 3. 4 to the 3. Y to the 3. Okay. Final answer. 27. Yes. Hold on 1 second. 27. X to the 3. Or x. What's the other way to say to the 3? Cubed. Cubic. Cubed. Three sides. And 64. Also what? Y to the 3 or y cubed. Yes. Yeah. Okay. This one. Because I have to. Because it's a what? It's a power inside of another what? It's a power of m inside of a power of n. Okay? So, oh, I see what you mean. Why do I? Okay, everyone, technically, do I need a bracket around the a? Only if it's a what? Only if it's a negative number. So I guess you kind of are right. I technically did not have to put it there, but I'm just gonna put it there just in case. And I apologize. I didn't know why. I think I just wanted to make more brackets. So you know what? Oh, okay. To your point, everyone, let's rewrite it by what? Taking out this inner bracket. So just write a to the what? M, and then all to the what? Okay. What does the rule say here? The rule says if you have a power inside of a what? Inside of a bracket of another power, you end up just having to what? Multiply those two. Multiply the m and the n. By the way, this is one of the most common mistakes in writing exponents. Many people, instead of multiplying, they what? They no, they add. Because to them, it's like, oh, it's like this one. Are those two the same? Everyone, are those two the same thing? No, they're not. One of them is a power inside of a power. One of them is a power, what? Times. Here you what? What do you do with these two? Come on. Here you add. Here you what? Multiply. You will still make that mistake sometimes. That's fine. That's how you learn. So everyone, that's wrong. So I'm going to take it out. And what's this equal to? A. And what do you put up here? M multiplied. Done. Thank you. Everyone, can you just write this? Remember, variables don't need multiplication signs. You wrote, yeah, I'm just showing you multiple ways of writing it. Okay, let's apply this rule to the 4 exercises we have. So what's the first one? Okay, very basic thing. So 6. By the way, what's another way of doing this if you don't want to do the rule that we learned just now? Bed mass. Again, do the same thing. What do you do first? First, you do what? 6 to the power of what? 6 to the power of what? No, no. You always do the inside first. 6 to the power of what? 3, which is 216. And then 216 to the power of what? You see, always start with the smaller shell and then expand outside. Never go outside in. Always go inside out. So I'm going to do it both ways for you. So the first way is the easy way, or easier. By the way, did I need a bracket here? Okay, so let's write it again without the bracket, just like this. Yeah, I don't know why I kept putting the brackets. I guess just because I want to put the base in a bracket. Okay, so what's 6 to the power of 3? 216. To the power of what? 2. That's a big number. Well, not super big. 216 squared. Oh, no, my bad. 216 squared. 46,656. What's today's way? What do I do with the 3 and the 2? Do I add or multiply? It's great. It's a force of habit because we did so many of the multiplication case. That's why. So 6 times what? 3 times 2, which to Kareem's point, for example, I can just say 6 to the what? 6 to the power of? No, no, no. 3 times 2. Still adding in your head. 6. 6 to the 6. What's 6 to the 6? I do you have to guess. It has to be what? Has to be this one because they both agree on the same way. And I'll show you. 6 to the 6. Regular. Look, 6 to the power of 6. Done. If it doesn't work, I shouldn't be teaching it. 46, 656. And let me just squeeze. Done. Okay. Now, do I need a bracket here? Why? Because my base is what? My inner base is negative. Okay. Again, how many ways are there to do this? 1 or 2. Always what? You can do the inside first and then expand, or you can do the rule we learned yesterday. Let's just do it the way we learned yesterday. Everyone, what do I put here? Come on. What times what? 3 times. You do it as you see it. If it's negative, you have to put it as is. So 3 times negative 2. So this is negative 6. Whoa, what is that? Nope. What rule is this one? Is it today's rule or yesterday? What did we say yesterday when you have a negative exponent? What do? You do 3 things. Number 1, you flip. Number 2, your negative exponent becomes what? Positive. And what do you put on the top only? 1. So 3 things. You flip, you make the power negative, sorry, you make the power what? Positive because it used to be negative, and you put a 1 on top. So basically, how does this translate to what I said? You put 1 here. What does this minus 6 become? Now, does this one become positive too? How many people say that 6 at the bottom should stay negative? Yes, everyone. You do not change the sign of this one. You change the sign of what? The top, not this one. This one stays what? Thank you. Okay. What's minus times itself? 6 times. 6 times. Pair, pair, pair. Positive. Whenever you multiply a negative by itself an even number of times, what are even numbers? 2, 4, 6, 8, 10, 12, 14, blah, blah, all that. So this becomes a positive. Okay. What's 6 times itself 6 times? I don't know. Okay. It is the same thing. So 4, 6. By the way, you can put the comma. You don't have to. I guess I'm putting it for today. What was it? 6, 5, 6. Good. Nice. You see? By the way, everyone, listen up. Oh, is it? Muhammad, I'm multiplying minus by itself how many times? 6 times. Minus, 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 minus. Those two become positive, those two become positive, and those two become positive. Okay? By the way, everyone, listen up. Guys, do you see that I could always give you what? An exponent problem where you have to use more than what? More than one rule. More than one rule. You see what I mean? I don't always have to give you an exponent problem where, oh, Mr. Ramadan, I had to use the zero. No, not zero. The zero just makes everything one. I had to use the flip, and then I had to use the multiplication. Yeah, I'm fine with that. Don't worry. I'm not going to give you a problem where you have to use all 5 or 6 rules. That's just way too much. The maximum number of rules probably you're ever going to have to use in an exponent problem is just how many? Probably 3. So maybe like a flip, and then a distribution, and then the negative rule or whatever. But I'm not going to give you a horrendous one with so many rules to do. Okay? All right. It doesn't test anything then. It just confuses you. All right. Almost done. 2 to go. Whoa. All right. Let's take it slow. What should I do first? Uh, what is the rule we just learned a couple of minutes ago? Is this a power to another power? So what do you do? Everyone, box these two or circle them. What do you do with these two? Let's do that. So just keep this one as is, minus 3 to the power of 5. And then you multiply what? Minus 2 times 2. Okay. What's minus 2 times 2? Not 2 times 2, minus 2 times 2. Minus with a 4. So this one goes minus 3 to the 5, oh, sorry, over 5, and minus 4. What did we do yesterday? What do you mean flip? Is this the 1 over or just the flip of the fraction? Just the flip. What's the flip of minus 3 over 5? 5, 5 over 3 or negative 3? The signs stay the same. You're just putting top, bottom, and bottom, top. So this becomes what? 5 over 3 negative. But now what's the good news? This one becomes what? Positive 4. And now what do I do? The 4 attacks each level. So I'm just going to start here because I want to give myself space. 5 to the 4 over negative 3 to the 4. What's 5 to the 4? 625. What's negative 3 to the 4? Well, I know it's positive for sure because negative times negative times negative times negative gives you positive. What's 3 times 3 times 3 times 3? 81. Do you think this one simplifies? No way. The original one doesn't. We're good. Okay. Last one. Ooh. No problem. What do I do first? Do I multiply the 3 by minus 3 or do I multiply the minus 2 times 4? Say again? Yeah, I could do the inside first, but that would not be using today's lesson. So let's use today's lesson. Okay. What would this be? It would be negative 2 times 4 to what power? 3 times negative 3. Okay, let's keep going. Can you multiply this now? Yes, let's do that. So what's negative 2 times 4? 8 with a negative. Thank you. And what's negative 3? Sorry, 3 times negative 3 or negative 3 times 3. What do I do? I have a number to a negative power. What do I do from yesterday? Flip. You put a 1. What does this become? Positive 9. What does this become? Or does it even become anything? Does it stay the same or change? Thank you. The base never changes. Without even punching anything in. What's a negative times itself? 9 times. Why? Yes, because The first two will pair, the second two will pair, the third two will pair, the fourth two will pair, and there will be what? The ninth one will not pair. So it's negative. Wow, what's 8 to the 9? Not super big. Yes. 134,217,078. Question for you. If the number is that big, can you just leave it as 8 to the 9? If the number is that big, are you permitted to leave it as just 8 to the 9? What do you think? Yeah, because honestly, what's the point of writing a number that's 9 digits and you didn't even calculate it? You just punched it in. So everyone, let's just say what? Negative, and I'll leave some space here, not too much, just some space to say this negative was done by itself, and then just 8 full marks. That's it. If you want to write the long number, if you want to write 134 million, blah, 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 sure, go for it.